All right, this is a Duck Talk. My name is Ryan Boyd, co-founder at MOTHERDUCK. There is my Twitter handle. Feel free to reach out to me if you have any questions. I'm feeling very echoey up here. I don't know if it's my loud voice or something, but feel free to reach out to me if you have any questions about this talk. MOTHERDUCK is invite only, so if you want an invite code, that's next to the ducks up here. These ducks can leave when I'm done with my talk, so feel free to take ducks too if you have any kids and want to bring them home. All right, so centralized compute. For those of you around back then, 1940s, 1970s, probably not much of this crowd, but there were mainframe computers. You would take your program card decks, your punch card decks, and bring them to an operator, and they would execute them, which was great if you were at a large enough company or a wealthy enough academic institution. And they really introduced computing to the world. But they were powerful. They provided this centralized compute. They provided shared access, a little bit of equality if you were at one of these institutions. But they were also bulky and expensive and not very personalized. Then came the PC in the 1980s. They really popularized computing because they were dedicated and personalized. Because you didn't have to worry about your work impacting the work of others, and you could run your programs whenever you wanted to, however you wanted to. I'm here to argue that the cloud data warehouse, I think, is the modern day mainframe. It is configured to work best for the operator and the administrators and not for the average user. And it's really not personalized for the individual. Yet as I'm standing here, I have a laptop that has 32 gigs of RAM and 10 cores. It sits idle at least 85% of the time. So how do we take advantage of this compute power that is sitting idle and also take advantage of the collaboration and scalability of the cloud? Now here's the next really bad dad joke. That would be just Ducky, wouldn't it? So this is what DuckDB is all about. So I'm going to be talking about open source DuckDB. I'll talk a little bit about MOTHERDUCK and how the two interplay. But most of the beginning of this talk is really around the open source DuckDB, which is written as an in-process SQL OLAP database management system. A number of us speakers are traveling around, and we were at dinner, and I mentioned the term OLAP, and someone was like, "What are you, like ancient? Why are you saying the term OLAP?" Apparently, that's not the fad nowadays. But I didn't write this. This was written. Sounds kind of academic. That's because it is. It was written by Mark and Hannes, the creators of DuckDB, who created DuckDB at CWI, which is the Dutch National Computer Science Research Institute. And today they run the DuckDB community and foundation, as well as a consulting company called DuckDB Labs. So what does this mean? Breaking it down, in process means it runs inside Python, inside R, inside C++. It's essentially a library. It's a 20 megabyte library that you can include in your code. And they build it specifically to have no external dependencies. They rewrote, for instance, the parquet parsing library to make sure that they could parse parquet files without all the extra stuff that was in the library. And it is meant for analytics. So full SQL support. Actually, Lizzie going before me makes a lot of sense because a lot of people first try doing their SQL with Postgres. And so DuckDB has based its SQL support largely off of Postgres. But then it adds some additional capabilities specific for analytics. And it's a different type of database, so it enables the high performance aggregations. Oftentimes, it's referred to as the SQLite for analytics. For those of you who aren't aware, SQLite is probably the most widely deployed database in the world. If you pick up your phone, you probably have 10, 15, 20 copies of SQLite running on your phone, or at least sitting on your phone, stored on your phone. Your computer, the same. Because SQLite basically brought a lightweight library for transactional workloads to all sorts of applications. And DuckDB just adds kind of the analytical support. Why did they create it? Why did Mark and Hannes think that it was important to create another thing like SQLite, except for analytics? Well, so they're academics. They have a lot of colleagues doing research, in particular in like the social sciences and all. And they were using R and DataFrames in R. And Mark and Hannes are real database geeks, and they came along and said, hey, why are you not using a real database? Why are you just using these stupid DataFrame things? And their colleagues were just like, well, we thought about using a real database, but downloading it took forever, installing it took forever, and then there was all this network overhead, the socket connections, all of that jazz. Like, it was just too much work. And Mark and Hannes were like, okay, we'll solve that. So they initially solved it for the R community, and then they expanded out from there. And nowadays, it's probably much more popular in the Python community than the R community. But they say they still love the folks in the R community. So I would argue that DuckDB has become so popular over the last few years because of these criteria. It's simple, it's performant, it has a great open source community, and it advances quickly. So on making it simple, what they did was figure out how do we actually integrate with all of these other technologies that people are using. So pandas. In pandas, you might define a data frame like this, basically a list of dictionaries, and then you have your DuckDB code here, and you're registering the data frame with the DuckDB code. And then you can actually write SQL against your data frames. And not only can you write SQL against your data frames, you can actually fetch the results back out as a data frame. Or you can join the queries of your local data frames with something that's out there in the cloud, or with a parquet file, or a CSV file, or a local database. But you can kind of do interoperability between Pandas data frames and DuckDB and SQL. It also supports a wide variety of other formats. So this is an HTTP URL to a gzipped CSV file. And in that one line of code, I can easily look at that CSV file that's gzipped that's out there on the web. And not only can I look at it, but I can easily convert it to a parquet file in this case, again, with one line of code. So these are the types of sort of developer usability things that the DuckDB folks added to make it super easy to work with data, no matter the format. So parquet files, and this case S3, but in a credentialed bucket, in a restricted bucket. You can easily do that. Select from and read parquet. It discovers the columns and all itself. And so you can read it, or you could actually read that parquet file and create a local table from that parquet file. In this case here, because I'm not actually using a file name, this is actually an in-memory database of DuckDB. So that trivia table would be in memory in that process. You can even integrate with Postgres. A lot of folks seem to abuse Postgres for analytical queries. And so if you really want a real analytical database, you can attach to your Postgres transactional data, pull it over, use it for analytics, and even I show another example here of copying it out to Parquet files. So this simplified data access is one of the things that I think led people to really love DuckDB. And the thing that's most interesting, however, in my mind, is the in-browser. So WebAssembly, WASM, you can actually run a full copy of the DuckDB engine inside your web browser. And that's exactly what we do at MOTHERDUCK for our web interface. And that's what a number of BI vendors and such do nowadays as well, is run that SQL engine in the browser. So now when you get results back, you can actually filter and sort and things like that. But you can filter and sort using SQL, not using JavaScript, which is pretty awesome. So it's performant. Databases are purpose-built for different types of workloads. There are several different types of database engines. In a row-based database, such as you have with Postgres or SQLite, it's really great for transactions. It's really great when you need to work with an entire row at a time. It's a very low memory footprint because you just need to fit one row into memory in most cases. But not very good for aggregations. What you do for aggregations is columnar. You basically structure it as columns in the underlying data store, and those columns are easy to access. They often have similar types of data in the columns, so they become much more compressed. It also, when you're doing aggregations, usually you only care about a couple of the columns at most. You don't care about the entire table. And so it allows you to just load that into memory. But a lot of engines will load the entire column into memory for the analytics, and that's where the vectorized execution comes in, which is used across DuckDB, but also a lot of the other modern analytic engines. But it breaks it down into row groups, breaks it down into chunks of data within those columns. And this is great because you can actually take advantage of CPU functionality to do the same instruction on multiple different chunks of data at the same time. And it can also really take advantage of the location of the caches. So modern memory, you have the L1 cache is your fastest way of accessing data from the CPU. The L2 cache is next fastest, L3, and then main memory. My caches here on the M1s are pretty darn huge. It's amazing to me how quickly the M series, the Apple CPUs, really advance these things. But in many cases, it's much smaller than that. So kilobytes versus megabytes, et cetera. But anyway, so the L1 cache, the L2 cache, we can basically take each of those vectors and pipeline them through the caches to make it really fast when we need to access them. And I'm talking a lot about memory, and I've had DuckDB users who've actually used DuckDB for a while saying it's an in-memory database. That's not correct. If you start DuckDB on the command line, for instance, and you don't specify any file name, it'll access memory. But as soon as you specify a file name, it will use that file or create that file. And it doesn't even support larger than memory queries, so it will spill over to disk the intermediate results. What's kind of special about that file is it's actually very similar to the icebergs or the deltas and things like that. Columnar, partitionized, very efficient ACID compliant updates. The biggest difference is that it stores an entire database and not tables. And that's kind of where the root of DuckDB came from, is the social scientists wanting to pass their data around to different folks. And it's a lot easier to pass data around when you have one file rather than some S3 URL that you have to go off to get to a bunch of parquets. There are a variety of compression algorithms implemented in DuckDB. These are fairly simplistic examples, but I just wanted to show you, building a database as Mark and Hannes have done. There's a lot of different elements that add up to the characteristics which make it good for certain types of workloads. So a dictionary compression does just that. It stores an index to the dictionary in the column instead of the actual data. Then there's FSST, which is basically substrings, which is pretty awesome in that it basically looks and says where are things repetitive in your strings and stores just the substrings in a dictionary and references those. The important thing, though, is that they keep on building different types of compression into DuckDB. And this goes to the kind of regular advances that they're making. The original versions of DuckDB had, this was a size of a data set was 15 gigs. At 0.6, which was a year or two later, it was up to 4.8 gigs. So they keep on making it smaller and smaller. Now, no one cares about the cost of storage nowadays. Storage isn't where it's at. But if you can make it smaller, then in many cases, you can also make it faster to process because it's faster to load into RAM. And you can actually see what types of compression algorithms your database is using in DuckDB, and you get something like this. So it's not just a different compression algorithm for every column. It is actually a different compression algorithm for every row group within a column. So it looks at the data and sees like what is the most efficient compression algorithm for this data. You frankly don't need to see this. DuckDB just does it, but as database geeks, we care a little bit about what happens under the covers. Now, a lot of people will say DuckDB is for normal size data or small data or medium data. And one thing that I've learned is that the definition of what is small data or medium data or big data is completely different depending on who you're talking to. If you go to the Bay Area and say you have big data, they're like, well, how many petabytes or exabytes do you have of data? It's like, okay, you go to most places in the rest of the world and say big data, like 100 gigabytes might get you there, or a terabyte might get you there. So it's completely different. But it does lead to interesting quotes like David here. The vast majority of the organizations in the world do not have greater than billion row data sets, but they need the benefits of data. This is why he's excited about DuckDB. It affords the power of an expensive cloud data warehouse without the complexity for smaller data for all. The part that I like about this is without the complexity, in that they really tried to nail down and make DuckDB work without you having to do much effort. It also works for larger than normal size data. Notice I didn't say big data. Our company is pretty well known in part for the blog post "Big Data is Dead," which is meant to be a hyperbole to get before that. But what do you define as big data? This is from Mim, who is actually at this conference in Brisbane. He said, "The irony of life, I have never done a query on a billion row table, but when I did, it was on my laptop using an in-process database." So I have some examples here of New York City taxi cab data doing queries on 1.5 billion rows. First is on my laptop. So I'm querying directly from the parquet files in this case. 2.95 seconds, getting this aggregate trip distance of all the taxi trips, querying across that 1.5 billion rows. And if I load that data into the DuckDB native format, we get 1.5 seconds on that 1.45 billion rows. And then I said, okay, well, what about if I take this to the cloud? And we can actually reduce that performance or increase that performance pretty significantly here, reduce the time. And this is by no means the largest instances of EC2. And largely, this is not taking advantage of the memory. This is just taking advantage of additional cores. But 1.5 billion rows of data in 145 milliseconds ain't so bad. The open source community is great. This is how it has moved in GitHub stars. This is how it moved on DB engines, which looks at like search logs and things like that. There's 240 contributors on GitHub, a few thousand members on the Discord. There's a community newsletter that is done by, it's hosted by us, but it's done by a community member that has almost 4,000 subscribers. And they keep on building stuff. Which is really awesome. These are a couple different releases. I'm not going to go through each of these with you, but if you look over this, these are 3-month release cycles. They really keep on doing a lot of excellent work and keep on advancing DuckDB. So we're at 0.8 right now. 0.9 will be out shortly. At 1.0. They will stabilize the file format so that it's easier to use going forward. Right now, they're still giving some flexibility with that. So that is DuckDB, open source DuckDB, created at CWI by Mark and Hannes. This is Hannes with his pet duck. His name is Wilbur. Wilbur is no longer with us, but Wilbur is where the name DuckDB came from. So we all like to have our homage to Wilbur here. Not to mention, if he really was picking at Hannes's eye, that's kind of funny. So who the duck is MOTHERDUCK? Who are you guys? We are a venture-backed startup, data geeks from all of the different data companies, trying to make analytics awesome. And this is actually kind of the root of a lot of questions that we get is, what is the point of a cloud version? So that's what we're doing, is a cloud version. What is the point of a cloud version? Isn't DuckDB meant for local? And I argue, actually, that my laptop, this is one of our stickers. I think I have some up here if you want some. My laptop is faster than your data warehouse. So yes, these things can be true, but it can also be true that you want to take advantage of both your laptop as well as the power in your cloud. So what if your query plans could decide whether to bring the compute to the data or the data to the compute? That's really what we're aiming to do. So if you look at our architecture, we have the clients, whether it be the web UI or whether it be Python in a Jupyter notebook or the command line client, they're all running a full copy of the DuckDB engine inside of them, connected to our server, which runs a copy of the DuckDB engine. Remember, it's only a 20 megabyte executable. What this allows us to do is actually do the query parsing and planning on the client and not on the server. And that allows us to do some nifty things like this. So this is data that is on the server, the New York City yellow taxi cab data. With passenger counts, we're trying to get the average total cost. And in this case, the total cost is in US dollars. But what if I want to get it into a different currency? I should have done, you might see here faintly, is I have the data for currencies in a local file here, a local CSV file, and I want to get the data in euros, and I should have done Australian dollars, I apologize. But I want to get the data out in euros, and I have this lookup table locally. I don't really want to put it into the data warehouse. I don't want to maintain that. I don't want to have to get people's permission and all. But I can still just do a join from my data that's in the data warehouse to my data that is local. And you can see the query planner actually decides here, okay, this part is going to be processed remotely on the server. This part is going to be processed locally. And in the end, you get the result joining together the query outputs from both local and remote processing. And then in MOTHERDUCK, we actually do this in the web UI in MOTHERDUCK. All the query results, when you execute a query, come into this viewer here called TAD. But in the TAD viewer, it's actually running a copy of DuckDB. So if you sort it, you filter it, et cetera, all that's happening locally, not going back up to the data warehouse. So MOTHERDUCK basically takes the cloud functionality that you expect, like collaboration, sharing, scaling, and adds it onto DuckDB. It's really awesome that if you run DuckDB, instead of specifying the name of a file, you can actually just specify MD : and the name of the database, and that will connect to MOTHERDUCK. So it's kind of like we'll download the MOTHERDUCK extension and automatically work. Really easy, and that's made us very popular amongst all our partners because the implementation has been super simple to go from one to the other. Another example here, you'll do an OAuth loop for credentials. We can create a remote database. Then we can open a local database, and we can join between that remote database and that local database just as we would normally with SQL. So DuckDB is about your laptop. MOTHERDUCK is about scaling into your cloud with this hybrid execution capability. And one of the more exciting use cases I've seen that we've been talking a lot about is the local development to remote cloud deployment production that is made a lot easier by having the same database engine in local and remote. So a lot of people we know that are using things like Snowflake, they'll have a local database that uses a similar but not identical flavor of SQL. And then when they do their tests, it will translate the SQL for those tests locally. Everything succeeds, they'll push to production. But they're really running a completely different type of database locally and remotely. And we see a lot of value there with DuckDB and MOTHERDUCK, labeling you to do your testing on the data engineering side locally. So you can find more at motherduck.com, and you can reach out to me on Twitter at RyGuyRG, and I will take questions for a minute.
Maybe 2?
2 minutes. If you ask a question, you can come up and get a duck. How's that? It's not as nice as headphones, but everyone gets a duck that asks a question.
And they're yellow.
And what?
They're yellow.
And they're yellow, yes. It's better than the black headphones.
Oh, that was quick.